everyone, today we are going to learn how to communicate an application load balancer to a Lambda function. First, you have to understand what is an application load balancer, and also I use Pulumi to deploy my serverless project. So this is the project diagram. Let's dive into the code. We need to create a basic VPS with specific networking parameters. In this case, I named the VPS. And the seer block, the VPS is assigned a seer block of this. We have a large number of IP addresses, as you can see here. And then the ability zones. This VPS is configured to spam across two ability zones. And the VPS includes a public subnet named public ESS subnet. I will not use a NAT gateway because the value here is none. And then we have to create a security group which allows HTTP traffic to the load balancer. The security group is named load balancer CF, and we have to associate the security group with the VPS we created before. And in the ingress array, we have to define the inbound traffic rule for the security group. The rule allows TCP traffic, and the port range. It specifies that the rules apply to the port 80, which commonly is used for HTTP traffic. In the steer blocks is part of the rule, which allows incoming traffic for any IP address. Now let's move to the load balancer. The creation of the load balancer has two configurations. The security group ID, which is associated, the public subnet of the specific VPS. And the name of the load balancer is load balancer. Now, we need to set up the target group, named target group, which is configured to route the traffic from the VPS to the AWS Lambda function, as you can see here. Now, a listener, we have to create a listener. The name of the listener is listener. This manages the traffic flow. This is for defining how the load balancer responds to incoming requests. Because now it's listening in the port 80. Also, we have to define the load balancer with the RN of the load balancer we created before. Then now the creation of the Lambda role. This Lambda role is created with a Lambda policy. In the Lambda function, it's defined with a specific runtime package, also with a specific code, and the file of that code is here. You can find here in the Lambda folder. And we have to set up the handler. And lastly, the role we have created before. Now, the creation of the Lambda permission. We have to grant the application load balancer permission, and it's linking it to the target group defined earlier in the code. We have the elastic load balancing and the target group we have created before. Lastly, we have to create a target group attachment. The reason is we need a group attachment for a load balancer, and we have to link the Lambda function here. We have to link the Lambda function that depends on option insurance. Also, we have to attach the permission of the Lambda function, because this allows to execute the role. And then we need the DNS. The DNS is very important because this makes it accessible for other parts of the application. Then for deploy this project, I have to use two commands. The first one, pulumi app. As I told you before, I am using pulumi to deploy all of my projects. The pulumi app is a command that facilitates the deployment and management of the cloud infrastructure. Before, you have to set up your tokens, and you can find more information in the Pulumi documentation. But for this project, I use Pulumi app, and the other, which is Pulumi, it's not here, is a Pulumi stack output. The Pulumi stack output command helps me to retrieve and display the output values of my Pulumi stack. In this case, it's not here, the response is this one. Now I can see the load balancer entry point, which I can access to the resources. And I hope this video helped you. See you in another one.